Hey there. So, welcome to the next lesson. The next lesson is about regular payments of annuity. So this is nothing new. It's like the previous lesson, except you have to know when to use which formula. So let's take a look here. So, when to use the amount annuity is to determine the accumulated values of regular payments. So if you're putting a money in the bank and it's building up, that's when you use this formula right here. And it's typically to save money for a specific purpose when you put money into the bank. So that's the only scenario I can think of. Maybe there's another scenario, but the most common scenario is to save money up in the bank. Present value annuity. That is when you're like taking out money or getting a loan, so you're borrowing money. So if you borrow money from a bank, or you borrow money to get a car, they're gonna charge you interest on that. So you're more likely to pay like a larger payment than you should because they're collecting interest. That's how they make money on loans. So, withdrawing money from a bank, that's one way, and taking a loan from a purchase of an item, like when you get a mortgage or when you buying something, and you're taking a loan from it, like you're buying a car, and you're gonna make payments back. So to solve these problems, you're using the regular formula, except you're gonna rearrange. Like the questions they're gonna want you to ask is what are the regular payments? What is R? So basically, you're solving for R. And all you have to do is rearrange the equation. If you know your math, you know your algebra, you should be able to rearrange this equation. I've done it for you. It's here. So you rearrange the equation so you have R equals everything else. So it's already done for you. So you already have the formula. And the best way to understand this stuff, and the best way to know it, and the best way to be able to solve these problems is to do examples, do a lot of problems. So let's read the first one. And I want to emphasize that you should do the homework because there's no better way to learn than do the homework. Like you can listen to me and you can look at the answers, but it's not going to help you as much as if you do the homework yourself. Okay, so let's take a look here. Brianna wants to save $6,000 for a trip she plans to take in 5 years. So she's saving. She wants to save. What regular deposit should she make at the end of every 6 months in an account that earns 6% interest per year, compounded semi annually, which means it's twice per year. So she's accumulating money. She wants to accumulate $6,000. So in this case, when she's trying to accumulate money and she's making regular payments, she's going to use this formula here, amount annuity. So first thing we should do is we should write down the information we have. This is basically the grasp technique, and I just like to call it just putting what you know first. Okay, so what do you know? Well, we know. Let me just get my tool here. We know that she wants to save up, and that'll be A. She wants to save up $6,000. Okay, and the interest for this in this case will be uh 6%. So it's 6%. That's per year. This is 6%. But when is it compound? It's compounded semi-annually. So divided by two. This semi-annually is two. So it's basically compounded twice a year, and that will equal 0.03. There we go. And how many periods do we have? Well, it says here it's compounded 6 months, every 6 months, and I know they don't. It's basically every 6 months. Well, it's compound, so he's gonna take 5 years. So 5 years, and it's semi-annually. So essentially, it's basically 5 times 2, which is 10. Right? And they sort of try to trick you with the 6 months here because 6 months is basically half a year, which is semi-annual. So this doesn't really matter, really. It's just to confuse you. Okay, so we have all the information we need, and we are going to use, I guess it's accumulating, so we're going to use the amount. amount, and see, we're using the amount annuity. That's hard to say. Annuity. And we're going to use the formula. And this is the formula that's been rearranged. So because we're trying to find the regular deposits. So let's go down here. We are trying to find R. That's what we're trying to find. And I rearranged the formula for you earlier. The formula is A times I over brackets uh, 1 plus I, and this N, and minus 1, and N brackets. There we go. And let's drop our numbers in. We have 6,000, and our interest is 0.03 divided by, and let's put 1. Where's the bracket? 1. The interest again is 0.03 and bracket, and it is 10. The period is 10 and minus 1. And you drop that in the calculator, you should get 523.38. So therefore, therefore, just so you know, the therefore symbol is this, so you don't actually have to write therefore. You can actually use the symbol. The symbol means therefore, and therefore, uh, Brienne, or she, I can say she. I don't like to use names. The names are difficult to spell. Will have to make payments of, this is in dollars, $523.38. So those are the payments that she has to make. Okay, on to the next problem. Okay, let's take a look here. Let's read this out loud. So, Donald borrows 1200, or I can say 1,200 from an electronics store to buy a computer. He will repay the loan in equal monthly payments over 3 years. So this is a borrowing thing, and you're paying it back. And he's most likely to charge you interest for it. So I can tell right away this is one of those future payments, just based on the situation. So monthly payments over 3 years, starting at 1 month from now. That's sort of useless information. You don't really need to know that. I guess that's just to confuse you. So I'm just gonna scratch it out because it tries to confuse you. He charges. Oh, did I spell that wrong? He charges interest. Oh, why is it 12? Okay, that's a typo. He charges interest at a 12.5% per year, compounded monthly. So it's compound monthly. Okay, so let's write down what we have. Again, I can tell right away this is going to be a future payment because you're borrowing money. It's like basically a loan. And those are future payment problems when you're borrowing money. So we have PV, which is 1,200. And then we have the interest, which is 0.12, 0.25 interest. And this is per year, but we have to convert it into monthly because it's compounded monthly. So to convert this into monthly, you're going to divide it by 12, and then we should get a rather large and ugly number. You don't have to use this ugly number. You can actually use the fraction. You can use the fraction. But I like to write it down because it's a lot easier to understand when I write it down as a long number. So that's 0.104167. I think the number goes on. And then how many periods? Well, it says here for 3 years. So we have 3 years. Again, it's compounded monthly, and there's 12 months in a year. So 3 times 12, we get ourselves 36. Okay, I think that's all the information we need. Again, I've written the formula up there for you. This is a future payment problem. You would have to rearrange the formula to isolate for R. So what are the regular payments? Okay, R. Okay, let's write the formula down first. It's PV times I divided by, and then we have this bracket here. We have 1 minus bracket 1 plus I, and then minus N, and that's it. There we go. Drop our numbers in. PV is 1200 or 1200 times I, and 0.0104167. Very, very ugly number. And then right here, divide all that here by bracket 1 minus plus 1 plus the interest again, another 0.104167 and bracket, and then it's minus n, which is 36, and that's it. This brackets, and then what we should get is about $40.14. So there we go. Then we just need a final statement here. The final statement you should write, therefore, and this is the symbol for therefore, I'm gonna say he pays, his monthly, or he pays, pays $40.14 monthly month. There we go. That's problem is done. Okay, let's look at the last problem. Here we go. Okay, so we get determine what type of problem is. Sherry borrows. Okay, so she's borrowing money. So that immediately tells me that's a future payment problem. And it says that she can repay her loan in two ways. The interest is compound monthly. Okay, so and then it gives you option A and option B. Okay, so this is another future payment problem here, I believe, because he's borrowing stuff. So let's get started. So option A, okay, let's write down the information we know and what we're looking for. So what's the information that we know? Okay, so we know what um here. We know that the the present value will be that is 9,500 or 9,500. And let's write this down here as well. We know that it's going to apply to option B as well. Okay, great. Let's get our interest. Actually, let me scroll up here so it's a little bit easier to see. Oh, there we go. So the interest in this case will be, well, it's 6.9 per year, so 0.069. And it says here it's option A, monthly payments. So if it's monthly payments, I assume it's compounded monthly. Let's take a look here. The interest is compounded monthly. Okay, that's correct. So it's compounded monthly. So this interest currently is in per year. We're going to transform that into monthly. So divided by 12, because it's 12 months in a year. And that is 0.00575. Okay, and now for solution B, it says there up here 8.9% year. So 8 point, oops, not that. So let me just erase that. Go back down here. It's 0.089. And again, this is right now right now the interest in years, so we have to convert that into the interest for months. So that will be, hold on, let me take a look. That would be 0.0074167. Okay. And how many periods? Well, this one here is for 60 months. For option B, periods, if you look here, it says there 60 months. So we have 60 months. That is done. For A, the period there is 36 months. Okay, because we're working, everything should be corresponding in months. The interest is months, the period is months, the interest is months, the period is months. Okay, so the last thing we need to do is to pop it into a formula. So let's move this up here and take a look here. So I wonder if we have space. I hope we have space. The save on space, I'm not gonna put the formula. I'm just gonna go straight into the numbers. So I assume you know what the numbers are. Okay, so let me just go back here. R. Here we go. The R looks kind of weird because you're looking for regular payments. What are the regular payments? And I'm just gonna drop those numbers in. Again, you know the formula. So it's 9500 times the interest, which is 0.0575 over brackets 1 minus 1 plus interest again 0.00575, and then this would be negative. Oops, let's go undo that. uh let's do that. Negative 36 and brackets, and here we should get 292 and 90 cents. Okay, this is the next one. This one here, again, it's the same present value, which is 9,500 or 9,500. I like saying 9,500. It's more orderly. And the interest, which is 0.00744167 there. And 1 minus 1 plus 0.007416. Again, that's the interest. And then end brackets. And how many periods there are? There are 60 periods. Over here, 60. And we drop those numbers in. And what do we get? We get 196.74. Okay, so these are the regular payments. Obviously, if there's fewer periods, you got to pay more, right, to reach that amount. But if there's a lot of time, right, then you can pay less, right? So there's an upside and downside to each. Okay, let's figure out the interest. Okay, let's figure out the interest. So we have here, let's put I for interest, right? And we know what regular payments are. Regular payments are 292.9. That's our regular payments. And then we're paying that off 36. 36. If you look back up here, it's the period is 36. So it's 36 payments. And minus, no, it should minus what the 9,500, because that is the future value, so 9,500. And over here is this one as well. The regular payments here is 196.74 or 74 cents. And how many periods there are? There are 60 periods. So you're making 60 payments. And we're going to subtract that by the present value. Again, this is 95 present value. And I'm gonna put here what this is before I give the final answer. So I believe it is um 10 5 10 5 uh 10 5 for 4.4 minus 95. So look at this. If you made these, if you made this, you made these regular payments, you're actually paying more because because like I said, they have to make money too, so you're paying more, right? Because you can't if you just pay the rate the amount, then they're not making money. So you have to pay a little bit more in those regular payments, so they get their money. So the people who gave you the loan are getting paid. For here, I believe it is 804 minus 9500, and finally I think we have a little space down here. I'm gonna put it down here. So the interest will be 1,000 and 1,044 and 40 cents. And I'm gonna put the interest over here. I guess can I put it down here? See if you can. I'm like I can't fit it there. I'm gonna put it over here. I believe the interest here is $2,000. So it's be 2,304.4. Again, if you look at this number here, it's larger. It's because the difference in that number is this number here, 2,300. That's they're getting paid. That's the amount that they're getting paid for giving you the loan. Okay, I think that's about it. That's the entire those problems there. There's nothing new. So yeah, good luck with the homework.